week we introduced this right time budgeting. We did a ton of case studies across two videos. I think most of the weekly quiz is based on those two videos where ma'am discusses a lot of case studies. Then we revisited this dispersion concept. We had covered it in depth earlier, I think 2 weeks ago, but there we did not go into this transfer function uh, treatment of this dispersion. Here we are discussing this because we want to understand how dispersion compensation happens, how material dispersion is something we cannot control once we've chosen the material, of course, but um, we can control the dispersion by designing the waveguide so that waveguide dispersion compensates for the material dispersion and whatever the dispersion accumulated over some length. This was the most popular method earlier. These days we also do DSD to compensate for dispersion. It's not a very complicated filter. And then we moved on to introduce these fiber nonlinear effects. How if we want to keep operating within linear region, we should not cross the 0 dBm threshold, which is 1 milliwatt. After that, we will start seeing some nonlinear effects. Why we only see them in higher power levels? All of those were covered in the last two videos in this week. So most of the quiz questions, weekly quiz questions, are based on those initial long videos about the case studies where we are using formulas from last 2 weeks or 2-3 weeks. So it's not just concepts covered in this week. So use formulas from earlier also. Then with from dispersion, I don't think there are any questions in the weekly quiz. And then we discussed nonlinear effects directly from the class video, I think, about surface modulation. There is a question in the weekly quiz. Today I was also supposed to show you this MATLAB program for this switch error rate and all this, but there is one small error I found. So let me fix that first. So no MATLAB. Yeah, that's all. Do you have any doubts also? Are there quizzes and exams going on in your institute?
Please, if you have any doubt, you can ask to regarding the MATLAB and that. Have you any exam in this? Because very less student will become. Anyone can respond? Manish? Manish, can you respond? Manish.
Also, Harshita, you asked something about. If there is nothing, a question start.
Manish, are you there?
Yes, yes, I'm there.
So, any issue is there that last class you are also not joined?
See, in last class, I was in office, so could not able to attend.
So, a very less number of the student have joined today. Also, they last class is also that. And you have any examination, so we can reschedule that class. We have remaining 3 class. We can reschedule if you have any problem with the timing and that day. We can put the request to NP till they will can reschedule that class for Saturday or Friday, Sunday, whatever feasible for as per
I
your.
Yeah, I think your suggestion is very right because everyone is quite busy in the weekdays. If you can arrange these, classes on the weekend, absolutely either on Saturday or Sunday, at any point of time. Means I think everyone is be free
So,
on weekdays,
okay, okay.
so that will be much better for us.
Priya, Devsri, Minakshi, Anim, Sri Arshita.
Yes, sir, we feel the same.
Sam, so Saturday or weekend is okay, fine for you?
Yeah, I'm okay. Manish this side.
But should we do in your evenings or should we do in your morning?
I think Jonek last 3 class we can reschedule for Saturday or Sunday, whatever that.
Yeah, but what time?
Timing
Anytime, anytime on weekends. Means
early morning.
this is my opinion. Rest also can give their suggestions. I am okay for any time on weekends.
Okay. I mean, man usually scheduled on Tuesdays because the quiz is on Wednesday, and the expectation is that you will do this during the weekend. And if you have doubts, you can ask right before submitting on that. And that's why it was originally scheduled on Tuesday. But of course, like weekends would be better. But on weekends, you might be going out and all these things.
Yeah, but we can, schedule our time for 1 hour. I think whole day cannot, go
Yeah,
outside.
yeah,
Out.
Jonek, फिर last 3 class we can reschedule on Sunday or Saturday on morning.
yeah,
Huh?
yeah, yeah.
It around 12 to 1 we have, can schedule that.
Yeah, sure.
Because in evening maybe some
11 to
person
12, whatever.
in evening other person will
Evening,
be busy with some things there, personal things there.
yeah, yeah, yeah,
So should you put the email to the team?
yeah, yeah, sure.
Okay, okay, thank you. So, as per brief summary given by the Jonek about that, in this week we have discussed about that link design, dispersion compensation, and that self phase modulation. About that, how self phase modulation will be, what is the role of the link design, which parameter will be affect for we have to consider for link design. Briefly explained by the Jonek to you, and now I will need your participation in the discussion. And if you have any doubt in the assignment problem or anything regarding that, before you can also ask about the week 1 to week 8 also. If you have any doubt that any questions or any topic, if you face problem that you have not understand through the class, or you want that we can include that topic also in the next class also, that you can message in the chat box your doubt, so we can include this doubt in the next class session. If any topic you want to understand from me or Jonek about the MATLAB code, regarding that any assignment problem, you have to submit it, but you have to doubt that how to solve this problem. So because you have the exam on like that 29 October, it is 29 October maybe that. So before session we want to include, even you can ask from week 1 to week 8 also. So if you have any doubt you can ask first, then I will be continue. Jagannath, Priya, Manish, Harshita.
Sir, will you help us solving the second question of assignment?
Second questions for week 9.
Yes, sir.
Question number 2 and 3 of assignment 9.
Okay, so for 2 and 3 for what?
Give me 5 minutes. Wait.
Apart from that, any doubt in that lectures content of that, any topic you have to face any problem?
Yes, sir. Sir, what about the final exam?
Final maybe 29 October maybe.
Sir, it is
assignment or
objective
what type
fill
of
up in the
question?
blank, sir.
29. What?
It will be objective type. I mean, the only thing I know is that it will be based on, like, it should be auto graded. But will it be fill in the blank, and how much is fill in the blank? How much is multiple choice? That only ma'am will know.
Sir,
I'll
voice
ask.
is not good, sir. Can you repeat once again?
Sir, not audible, sir. Sir, can you
Oh,
please repeat? You are not audible at the moment.
wait. Give me 5 minutes. Wait.
So Harshita, you have question about that. If 15 nanometer, 15 nanometer optical system has three space of length 80 kilometer, 120 kilometer, and 50 kilometer in sequence. That question.
Yes, sir.
So you have to given that three spine of length. Their optical fiber have the three length of one of size of 80 kilometer, and one is 120 kilometer, and one is 50 kilometer. In with the amplifier in between, it will be like that. One is 80 kilometer, then there is an amplifier, then is a 120 kilometer, and then there is an amplifier, and then 150 kilometer, then there is amplifier. Okay. The transmitter is directly connected to the fiber of length 80 kilometer. There is a transmission of the signal here, and there is a receiver. There is an iridium dope fiber amplifier in the output of the 50 kilometer as well. So we have the amplifier. After that, there is another amplifier. After that, the fiber attenuation is 0.5 dB kilometer. The single power from the transmitter is 10 milliwatt. So P transmitters you have to given 10 milliwatt. Attenuation alpha, your loss you given to 0.25 dB per kilometer. Okay. Now you have to calculate that what is the optical noise power spectral density at the output of the laser. So your noise density, the sigma noise density you have to calculate for that output of that amplifier. If a For first question, if an optical fiber of the bandwidth you have to given is 0.1 nanometer is introduced at output of the ADP, what is the on of OSNR, optical signal to noise ratio at output? So you given to you calculate the SNR for at the output, and you have to given that noise density at output. So what do you think that previously I have explained also that what is the loss, attenuation loss of total fiber? How can we calculate attenuation loss? Anyone can? Class, what is attenuation loss? So what is in this? For total fiber attenuation loss is like that. For 80 kilometer attenuation loss, how we can calculate? We can multiply alpha into L for L1 length plus alpha L2 length plus alpha L3 loss. So total loss in the fiber we calculate through the length of fiber multiply with the attenuation of that fiber. Okay. And in the previous questions you have to calculate gain of that system margin. For question 1 you have understand that because they are correlated for question 1 and 2 and 3. Both 3 are question are correlated. So from question 1 you have to calculate gain of for 80 kilometer, gain for 120 kilometer, and gain for again 50 kilometer you have to calculate. Then what happened that you have to calculate that the gain required at stage after 80 kilometer. What happened? This will be gain G1 equal to alpha into L. So what is 80 into 0.25 kilometer? So it will give you around like 20 dB per kilometer, or maybe if we multiply that. Similarly, gain 2 we have to calculate G2, that is 120 into 0.25, and G3 you calculate 50 into 0.25. Okay, have you understand, Arshita?
Yes, sir.
Now you have to calculate the noise density at the output of side of the EDF amplifier, that after the 50 kilometer how much the noise we receive at the receiver. So what happened that noise power density of the noise that signal we have to calculate noise figure plus gain of that first G1 plus we have to take tan log, that formula you mentioned tan log of HV. So you calculate V from lambda, V equal to C by lambda. From that you can calculate HV plus log of tan, that power output. So you have to given the power output 10 milliwatt, so it would 10 into 10 ki power minus 10 upon that 1 upon P out, so it will be 1000 something. Then from that you can calculate that for that first stage noise. After that 80 kilometer how much noise there, you can calculate this formula. After that second and third. Similarly you have to calculate for 3, and you can add all the 3 noise. Understand? From this formula. Hello? Manish?
Yeah, okay.
Now you have to calculate that you have to given the bandwidth of given the amplifier, and you have to given that signal to noise ratio, the optical fiber of signal to noise ratio. So you have to given that signal power minus noise power in dB. So your noise power you have already calculated through that noise power density, spectral density, and you have to calculate only the signal power. So you're given that bandwidth of that fiber 0.9 nanometer bandwidth. Through that you can calculate that signal power of that also signal. For it's calculate you are in the question first you have to given that data. Through that you calculate the signal power, and noise power you have to already calculate that for 1 and 2 3 stage, and after that you have to do the subtraction from signal power to noise power. You have get the value of that OSNR. Okay. Any doubt in these questions? For questions 3, it is given for 10 gigabits. Another intensity modulated system. The receiver is a simple pin diode with the responsivity. You have to given the R lambda equal to 1 ampere per watt, and that rate of that 10 gigabits. So the bit rate you have to given already. Load resistance you have to given RL equal to 50 ohm. Yes, Manish.
Yes, correct.
So electrical bandwidth you have to given that fiber that signal electrical bandwidth is 10 gigahertz.
10 gigahertz.
Okay, assume there is a no waveform distortion. We have the no distortion due to two waveform or three waveform, and considering only thermal noise and signal ASC bit noise. So there is a no short noise in the signal, no power noise or whatever other noise, Gaussian noise, Schottky noise, filter noise. There is not noise of that. Only you have to consider it as thermal noise.
Sigma T.
Okay, find the receiver sensitivity for Q equal to 7 with the OSNR. So from that bit error rate for Q equal to 7, how for Q equal to 7, how much bit error rate? I think that is 10 to the power minus 12 bit error rate. From that
Correct.
graph, previously I explained that bit error rate graph with the quality factor. So you have to give that quality factor to 7, and I think that value of the bit error rate is around 10 to
10
the power minus
minus
12.
12.
Okay, so so for the in case of that considering the zero power in the case of that quality factor, we have defined that I1 upon sigma 0 plus sigma 1. Okay, and for because there is one is the I0 and one is the I1. There is two signal, one is for that baseline and after that I1 is the amplitude signal. It should be sigma 1, I have taken the constant, plus sigma 1 square plus P as average square. This is a power density, this is thermal noise. So that formula previously I have also explained the relation between that power density, the noise density of that thermal noise with that sigma. So this square sigma square P square ASC, that will become. So I1 from that responsivity graph, I lambda equal to that formula N lambda I naught. You can calculate that I1, that power and that relation from that week 8 class. Through that you can calculate that sigma t from that also that class, and the total receiver power should be P signal power plus P noise power. So your in case of that OSNR should become like that, P receiver power plus P receiver plus P signal power in that case. So when you have to given that first case your OSNR is infinite, it means P power density of the noise at a receiver should be 0. So P receiver power you can calculate in that case. One OSNR is equal to 20 dB. From that you given that PS you can calculate in case of the 10 dB. From this formula you given all thing that. So in this question you can calculate P receiver and P noise power. You go through first and second question, you get both the things, and then you have to mention that value of OSNR, and from that you can get the P receiver value. Okay, Manish and Arshita. Hello.
Yes, sir.
Correct.
So you can calculate through that. Anything else? Any other questions?
See, I just want to ask one thing, that during calculation we are using, calculator or scientific calculator these days. But in exam, can we get this kind of facility?
In exam,
Yeah.
yeah, it will be inbuilt. Scientific calculator will be there. That like that in the GATE exam you have to maybe get that.
Okay. Okay.
I think John this way, or they have to carry that their calculator.
I actually don't know.
We will discuss that NPTEL team, or maybe we have to and then inform that like that.
Yeah.
Okay.
Because at home we generally find out either on the Google what is the value during of the calculation, and or use
In
the
your mobile there is also scientific calculator there.
Yes, correct.
You can install that app for scientific calculator, or you can maybe that they will provide that you scientific calculator like GATE exam like that.
Okay.
Okay. Or maybe you can put the query to that NPTEL team that your exam they will reply to you that
Okay. Okay.
for exam doubt and that. You can put one email to them that.
Sure. Sure.
Okay.
Okay.
Anything else that? Priya, Ankita, Kalyani, Meenakshi. So, can you explain that? First discussion question is what do you mean by the loss budgeting and rise time budgeting in the link design? In the link design, we have the two important parameters. We have one parameter is that loss budget, and another parameter is the rise time of budgeting in the link design. So loss budgeting is primarily decided by the following: that data rate, desired bit error rate, or receiver sensitivity. So we can calculate how much the loss budget due to that link only, and that rise time budgeting is that due to the pulse of the signal, how much the loss in the signal that. So the first thing to decide for link design is the largest data rate expected. So we need that largest data rate for that link design. This is followed by the identify the expected bit error rate, which is generally that 10 to the power minus 12 to 10 to the power minus 12 at quality factor equal to 6 and quality factor equal to 7. So we for any optical fiber signal link design, we have to consider that we have to send that largest data rate, and we have to bit error rate between should be 10 to the power minus 10 to the power minus 12. This can now be used to obtain the required quality factor at q equal to 7 q, which is further used to find the receiver sensitivity. Okay. So the next thing to decide that related to the fiber length is attenuation. Another parameter for link design: how much the fiber length we used, how much the attenuation loss of that fiber we have to calculate in dB per kilometer. Number of the splices loss or splice loss, how much the losses due to the connector splices between to the fiber through the amplifier, the connector between that amplifier to the transmitter, we have to calculate. We have to consider that losses also in the design of the link. So if the required transmitter power is thus computed starting from the receiver sensitivity, and after that have accounted for attenuation, splices loss should be in the transmission we have to include. We can calculate that loss budget due to that fiber on the forward direction only. By fixing the maximum power data can be transmitted at the source and tracing the power available at the receiver after considering all the losses. So we can, if we calculate the loss budgeting, we can always calculate a forward. We can through that start through the transmitter, and through that receiver we finish this. So how much we can fix that maximum power of the transmitter, and whatever the receiver power we have to calculate, and after that we take the difference, and then we can calculate how much the loss is due to that transmission. So this is the loss budget due to the transmission only. What is the rise budget, rise time budget? What is the rise time? Anyone explain that? What do you understand by the rise time? Anyone can explain that rise time?
I think rise time budget is basically to identify the bandwidth of the operation with the respect to the time.
Okay.
So suppose there is a linear system, then from at one particular point of time, when suppose there is zero time, then the how the output of the voltage is going to be change.
Okay. So in a Jagannath, like that in a control system, you have to say, put one signal like that in AOD, that this is the signal. Okay, we have calculated rise time through that signal. So we take the 10% to 90%. So the response that take from time taken by the signal to take the response from 10 to 90%, we take rise time. T1 at T2 is the difference between that 90% time, and this difference will give up the rise time. Okay. So yeah, your answer is through that we have to, this is the signal, we have to take the bandwidth at t equal to 0. So time and the state remain shown in the graph is that constant value that t is your graph. Now for linear system, we have considered for the linear system only in this case. So what happened that the entire system can be modeled as simple RC circuit. So whatever we can, that signal we can simply RC circuit we can model in our signal. There is RC. So previously I explained that the time constant of the signal is given by the T upon 1 upon RC is that system. So what happened that there is a V out and this is the V in. This is a time
Sir, there
signal.
is only low pass response
Yes,
because of the bandwidth.
I just explained that RC may be low pass and high pass. We can consider that not the filter we have to taken about take it. We have to just consider circuit maybe C is here and R is here. It may be high pass, but we take that whatever the capacitance of that circuit and what that load resistance of that circuit also that in that case to calculate that rise time to the receiver side of the signal. So the output voltage can be written in the term of the voltage V out that linear system you previously did that V out equal to V naught of signal 1 minus e to power minus T by RC that we have to say, calculate through this signal that is exponentially saturate that minus T and TRC. So if the T1 is the time taken for the signal to grow for 10%, this is a T1 where the 10% of the time is grow. This time is we can consider T1, and T2 is the timing where it will be saturated or it will be reached to 90% of the timing. So what we consider that timing depends that T1 is a 10%, so we take the 0.1% of V naught. You get a 10% V naught by 10%. This is equal to V naught 1 minus e to power minus T, the time of that is equal T and upon RC. Another thing is we can consider maximum 0.9 V equal to V naught 1 minus e to power minus T upon RC. Okay. So whatever the rise time TR equal to T2 minus T1. So if we take the difference of the T2 T2 minus, it will give you upon log 9 into RC. So it will come around 2.2 RC value. So T rise time equal to 2.2 RC. Okay. So for any circuit of the signal the rise time budgeting we can calculate that 2.2 times of the RC. So whatever the ratio of the load and capacitance of that receiver or that circuit, through this we can go calculate that rise time. So what is the relationship between rise time and bandwidth? If you read any communication signal and control system of anyone. Jagannath, have you remember any relationship?
So between the relation between the rise time
And bandwidth of that signal?
yes, sir. TR is equal to 0.35 by bandwidth
0.35?
divided by bandwidth.
Yes. So TR equal to 0.35 into bandwidth. It can be related delta F. We can in a communication like that delta F.
Yes.
So anyone can explain that what is the required bandwidth in digital communication system? How much bandwidth required in the digital communication system for a non-return to zero format or return to zero? If we have that bit symbol that B, we can modulation we can can consider that on off key or BPSK modulation in that scheme. So how much the bandwidth required in that format for return to zero and not return to zero format?
For return to zero, it's B, and for non-return to zero, it's B by 2.
For return to zero is
B,
okay, and for not return to zero,
B by 2, half. the bandwidth.
why?
Because it doesn't go to zero, no?
Okay.
Yeah.
Yes, Manish. So how can you relate the rise time in that case in both the case?
Rise time in case of non-return to zero, it's b by 2, then it will become 0.7 divided by bandwidth, and return to 0, it will remain same 0.35 divided by bandwidth.
Okay, okay, good. Good, Manish.
Thank you.
Does the fiber introduce any rise time constant? Tell me. Have you have calculated the effective allowed rise time from that individual rise time, that how much the rise time you can calculate of the
Yes, sir.
transmitter?
Yes, sir. It allowed.
How? Why? Why rise time constant will be happen in that case in the link design? How rise time? What is the reason for rise time constant?
So due
Sir,
to the material dispersion,
Okay. So if the material dispersion for that was the case for single mode or multi-mode fiber, it will happen in both case or not? If I have used a single mode fiber, then rise time constant will be there or not? Or if I use the multi-mode fiber, rise time constant will be there or not? Tell me. If I have the single mode fiber, then what type of disturbance will happen? Intermodal or intramodal?
that's intermodal one.
And for multi-mode?
intermodal, sir.
Yeah.
Intermodal, sir.
Intermodal.
And for multi-mode?
Intramodal.
Intramodal.
So multi-mode not have contain that intramodal. Multi-mode should have the both the dispersion or only that single dispersion, intramodal.
Dispersion.
Multi-mode should have the intermodal and intermodal both the dispersion, and it have only that intermodal dispersion.
Intramodal dispersion, sir.
Only?
Intramodal
So
dispersion.
it can be both.
Yes. In multi-mode we have the both the dispersion, but in case of the single mode model, we have in the single mode model we have
It's only
only
intermodal.
in only
Intermodal.
intermodal. Intermodal
Yes, sir.
dispersion is absent in case of the single modal dispersion. So intermodal
Yes, sir.
dispersion could be due to the material dispersion or waveguide dispersion. Should be that it will be, we cannot remove that intermodal dispersion. It will be due to the fabrication technology, or when we have the manufacturing that fiber, it will be inbuilt in that only case. So if we want to remove that case, so we have to take care during that fabrication of the fiber only. After that we cannot remove this material dispersion. So what is the T model in that case?
Sir, have one doubt, sir.
If you read the previous class you attended, what is the value of the T model? Time of due to that that intermodal dispersion?
Sir, length divided by velocity of light. Hello.
Yes. So it will be length of the fiber. This is speed of that light or signal. This is the chord diameter refractive index, and this is the collecting diameter refractive index. Okay.
Yes, sir.
So in
Sir,
case of
have
the
one doubt,
intermodal
sir.
dispersion, in term of that Gaussian wave dispersion, GVD, what is the value of that?
Yeah, Harshita, you want to
Sir,
talk?
it is d del lambda L.
D
Del lambda L.
D
The
lambda
mode of
L.
the
So D
this
is
is the
a
mode.
dispersion parameter. It should be the constant. So
Yes, sir.
usually represent in the formula in the picosecond per kilometer nm. Okay. L is the length of the
Kilometer
fiber.
nm.
Delta lambda is the spreading wavelength. Delta lambda is that case. So
Sir,
if I calculate that, yes, yes.
can you explain the case study, sir, in the link design?
Which case study?
Case study, sir, in the link design
Yes, yes.
topic.
That will I explain that. For there is a three case study. Which you want that?
Second case, sir.
Second, that passive optical network case study or that dispersion that.
Okay, sir. Passive network study can explain.
Okay, I will come on to that also. Okay. So in that case, if we have three component in the system, the transmitter, receiver and fiber contribute towards the rise time. So if if we filter that, the system is similar to that of cascade filter with corresponding to load transfer function. As transmitter of that fiber, as transmitter of the signal, as transmitter of fiber, as transmitter of receiver. So total net effective rise time can be written as, how can you, if a rise time can be written? If we have the S transmitter of the fiber, S signal transmitter of the receiver of signal and of that transmitter TX. So how much the total rise time we can calculate of the total system? Anyone remember the formula?
It should be the square of transmitter plus square of fiber plus
Fiber plus square of rectifier.
square of the.
Okay.
Yes, sir. This will
So
work.
okay. So I have one question. So, you are the optical engineer. You are working in the fiber company like that Geo and any optical Tata or that Reliance or anything, and you want to make that one line from that some company or some institute. You have to give the tender value that you have to make that electric in that optical fiber connection for transmission of that. Signal for signal that from that like telephone network or that that for internet connection. So what is your approach for that link design? If you are an engineer and you have to design the link that you have to connect a 3 to 4 department or 5 to 5 palaces, or you connect the city and you make that link between that one home and that base station, some offices, some hospital, some schools. So what is your approach for that link design? How you design that link?
So first you have to fix the required BR, and then Q and SNR according to the VL.
Okay, then you calculate first that bit
Then we have
rate
to find out the
bit,
average power.
you calculate the bit rate, you calculate a bit error rate, quality factor and SNR. After that,
Yes, sir.
after that,
Then we have to correlate with these factors uh,
okay,
for availing a transmitter power and loss budgeting, which can be carried out.
okay. If we know the fiber length, then what we can use that?
Then we
In
have to
case of
fix the
we know
required
that we have the
transmitter power.
100 kilometer of the fiber length. In one case, we do not know the fiber length.
Yes, sir.
In both the case, what can you do? Then what is your strategy? How you can plan that?
So we can do with the RZ signaling
What?
or NRZ signal.
Okay. So how you can choose the wavelength of that? Okay. How much the signal wavelength should be there? It is 1550 nanometer, 3050 nanometer, 1650 nanometer, 7050 nanometer. It's most dependent. Which which wavelength you use to transmit that signal?
Sir, we can sir, it can be choose on the loss or rise time for
Right
the
time
loss or
budget.
rise time.
Okay. And if we have used to dispersion compensation, then there will be dispersion, then we should be considered due to design or not that. If we calculate a dispersion compensation, we calculate that it will be losses due to the dispersion, and we want to
Yes,
compensate.
sir. Yes,
Huh?
sir. It should be considered. Yes, sir. It should be
And
considered.
due to the amplifier that EDFA or whatever amplifier, that silicon or germanium amplifier, it should be considered net.
So for amplifier, for first one it's considered, but for amplifier, it should
If
not
you
be
use the
considered.
EDP amplifier between that after that 40 kilometer or 28 kilometer or 60 kilometer, Then the amplifier have also some SNR
For
and some loss.
sir, yes, sir, it should be considered.
Yes. So you have to take care of the all the design. Practically first you consider that for theoretically whatever the bit rate we have to send, what is the bit error rate, what are the quality factor, and what are total signal noise. Then you have to consider that how much the what are the total amount of the amplifier we have to total amplifier we taken through the link design. It will be 3, 4, 5 after 20 kilometer you have to put, or after 60 kilometer you put. So we consider that loss also that. Then you have to decide that this is our loss. Then this is our the rise time budget that our signal. Then which wavelength is suitable for that to transmit that signal, so we get this output or the receiver sensitivity, we get that our desirable sensitivity. So first we calculate theoretically this component, then we have to put that design system any software, and then we see that the signal will be transmitted and we get that signal whatever the accurate signal we can get only. So that will be our transmitter power, and that should be receiver sensitivity. Okay.
Yes, sir.
Anything else? Suppose I have given one question to you, case study. Rise time of the transmitter receiver should be as that. T rise time of the transmitter should be 0.25 millisecond, and T time of the receiver should be 0.35 nanosecond. Okay, both are in nanosecond. D is given to be 2 at dispersion parameter factor equal to you are to given 2 picosecond per kilometer per nm. You use the single mode fiber. Spectral width of the source is 3 nanometer. So delta width of the delta lambda is equal to 3 nanometer. Link length is your length of the fiber is the 50 kilometer. You have to calculate desired bit rate should be that you require a bit rate in the output equal to 1 Gbps. Your required bandwidth bit rate should be 1 Gbps. It is possible to achieve this bit rate in this link or not? Guys, can we get the 1 Gbps at output side or not from this parameter?
Sir, we have to calculate the rise time and
For-
system rise time.
So can you that calculate that total? You have to calculate the net rise time of the system.
Yes, sir.
So transmitter rise time you have to given that 0.5 nanosecond. Receiver you have to
Yes,
given.
sir.
You could calculate only the T fiber time. So that
Yes, yes, sir.
fiber time you have to calculate through that formula that your intramodal dispersion time.
Then you have to add all.
D lambda that, and you have to calculate add all the three things T system.
Yes, sir.
Okay, and your bandwidth you have to that T rise time and bandwidth you given that 0.35 into that delta F, and your bit rate you have to given that 1 Gbps at that you have to calculate, it will
Yes,
come
sir.
around
So-
that 355
So-
picosecond.
The delta feature 1 Gbps, so equal to 0.35 nanosecond.
So you can calculate for that return to zero format and for the non-return to zero format, and you can find that which scheme can be used for signal transmission, is return to zero or not return to zero. Through that you
Sir,
can find
you
out that this will be possible through which signal through transmit through the return to zero format or not return to zero format.
Sir, how can I find out for not return to 0 and return to 0?
Bandwidth you have to given that na, one is bandwidth equal to in the case of non-return to zero 3.5 bandwidth I already, and in one case
Okay,
it is
okay,
0.7
okay,
and bandwidth.
Okay,
In
sir. Okay.
total time you calculate through the bot scheme, and the system time you have to given that in that case both case.
Yes, sir. Yes, sir.
Yeah. If your system time should be less than that time of that bandwidth, then how can you transmit that?
No, sir.
Okay.
Okay, sir.
So through that you can calculate this.
Yes, sir.
Now we have to go that Kalyani, you have asked the case study too.
So then
Kalyani,
we can find out its support return to zero, but not return to zero. It
Yes,
remains up
sir.
because the time is
So
350 and 700 picosecond.
so case history 2 that we take another example for passive optical network. Kalyani, can you tell me that what is the passive network and what is the active network? Have you know the difference between passive network and active network?
An active network consists of at least one voltage source.
What?
Active network is consisting of one voltage source or current source for supplying of an empty cell.
Okay, in passive network?
Does not contain any supply sources.
Okay, so resistant is the passive network or active net, active type device? Fiber is the passive network or optical active network?
Active network, sir.
So it will amplify or that transmitter through open supply it will generate it, or we have to give the external supply to operate that. So let us take that there is a passive optical network PON passive with the 2.5 Gbps is to be designed. So we have the bit budget is splice every 2 kilometer. We have one splice every 2 kilometer connector, and its loss should be for every splice is equal to 0.6 dB per splice. What is the maximum link length? What is the allowed load resistance? This is the questions case history one that Kalyani. Hello.
Yes, sir.
So you have to given that transmission wavelength you have to given 310 nanometer. P out you given minus 3 dBm. T rise you have to given 100 ps. Spectral width delta lambda you given that 0.2 nanometer. If the receiver side that receiver there is, receiver responsivity you have to given that detected 7 ampere per watt. Rise time of the receiver it will given that 100 ps of detector. Capacitance you have to given 1.2 picofarad. Okay. So what is the maximum link and what is the allowed resistance data receiver? So in this case, the required bit error rate you have to given, the responsivity is given 0.7 ampere watt. So the rise time of budget detector you have to given. So there is additional RC in the TI transmission. So there is a transmission fiber receiver which has a photodetector followed by the TI. So from that additional RC constant from T rise you have to given, and you calculate that RL through this T equal to 1 upon RC. Okay, so your that TR for that signal you have to given that 0.35 upon bandwidth. Through that you given the TR of the system. T square system you have to already define that T transmitted square of T fiber plus T receiver plus T additional data for that RC. So total T square system equal to T square transmit plus T square fiber plus T square receiver plus T square RC. So whatever required your T square RC should be less equal to T square system. Okay, should be less than or equal to T square system. So T square TRC you can calculate through the minus through the this system. So through that you can calculate TRC should be whatever that the TRC. And we have already get RC constant equal to 2.2 RC time. Okay, and through that RL you can calculate through 2.2 into CU given that TRC you have to calculate through this formula, and capacitance you have to given, and RL through that you can calculate. Kalyani,
Yes, sir.
okay?
Okay, sir.
How can we dispersion composition can be done in the fiber? Anyone tell me that? So there are many ways to solve this problem: internal model dispersion or intermodal dispersion in optical fiber. So one method we can use that 10 nanometer as the wavelength where the dispersion is almost is zero in that case. In the 15 nanometer there is a more dispersion than in case of the 10 nanometer, but that intersync attenuation of the silica is very high at this wavelength. Okay, so therefore the long distance communication we use that 50 nanometer. For short distance communication we use either 10 nanometer of the wavelength of that signal. Another is that we restricted the length of the fiber used to dispersion limited length. So from that intermodal you can that we calculate L into N1 square C N2 square. So we can control that length in that case, and we can control that dispersion. Carry out the dispersion composition, we can carry out through the dispersion compositions in many way. So for long distance communications we need to compensate that dispersion. So what are the dispersion? We have the broadening of the pulse in the fiber, that will be the pulse broadening in the fiber. So anyone can explain that quantification of the intersignal interference, intersignal interference? Because broadening of the pulse will be responsible for the intersignal interference. I have explained that 2 weeks before also class that also. I have explained also that group velocity and phase velocity of that signal. Plots bending time also I have explained that class. So we can calculate that dispersion in the single mode fiber through that MATLAB code is explained by the Jonek also, that how can use that calculate the dispersion in single mode and multi mode fiber that. So we understand that parameter. Through this we can pulse broadening and that everything that dispersion factor that in picosecond per kilometer nanometer we can minimize that in that case also. Limitation of the DCB based dispersion composition. Any limitation everyone know that? Dispersion
Sir, what is the
transmotion,
question?
dispersion transfer function
Hello.
limitation. Yes.
Sir, can you repeat the question?
What is the limitation of the dispersion transfer function? So this reduction in the core diameter has a two major disadvantages. If we reduce the core diameter, the fundamental mode speed or mode to the cladding, leading to more losses. If we reduce that core diameter to make the to minimize that dispersion, it will lead into that some mode maybe will be not transmitted at the receiver side. Smaller core is also inspire smaller area or increase in the intensity, leading to large non-linear effect. It will more dispersion in that case. So dispersion composition factor have therefore a much lower threshold for non-linearly composed to transmit fiber. So an increase in the bit rate would be lead the following. So if you want to compensate that dispersion composition factor, it will lead to increase that bit rate error. So this is value become, so tolerable dispersion value becomes small. If you have the more bit rate, transmission bit rate should be more, it will be reduced that dispersion composition factor. So dispersion composition may be required for even smaller length, smaller pulse need to increase the spectral control. Third order dispersion cannot be ignored. So this is the parameter through which we can, this is the limitation of that, we use that dispersion composition factor to minimize that dispersion in the fiber. But if we use this dispersion composition factor, this will be the effect on that link design. We have to minimize, we have to consider this effect also too. Explain the nonlinear effect in optical fiber. Also provide the origin of its effect. What is the nonlinear effect in optical fiber? What type of the nonlinear effect you know that? Manish, Jagannath. So we have the five nanometer self-phase modulation nanometer, cross-phase modulation, four-way mixing, stimulated Raman skirting, stimulated billiard skirting. This is the nonlinear effect in the optical fiber we have to consider. So origin of the nonlinear effect will be the dielectric material. The fiber will be made of the dielectric material. Through this we have this will be lead to the nonlinear. So nonlinear will become evident only when the intensity become large. Consider propagation of the electric field light E equal to e to the power minus j sigma beta z is the beta is the propagation constant, omega is the frequency, t is the time. So this is the electric field I have already said, mentioned in the diagram. So when the electric there is the polarization of the electric field in that optical fiber that will be given at alpha naught into x1 ex plus extra double e plus triple e times. Explain difference between a dispersion versus self mode diffusion. What is the impact of the SPM in the communication? So, self phase that modulation effect is a non-linear phase. Is can linearly with the power, limit the optical amplification, spectral broadening increase as the pulse width decreases, limit in the bit rate. We can limit that bit rate. Skew the constellation in case of the advanced modulation. This is the skew in the constellation diagram. This is the spectral broadening that pulse limit bit rate, and this case is the nonlinear field that in case. So this is the Fourier transformation, and this is the bandwidth that delta omega is the bandwidth. So in case of the dispersion, this is the pulse spreading, and in case of the self phase modulation, there is a that intensity will be increased in that case. That signal intensity will be increased. In case of dispersion, there is a shift on frequency. In case of that, in the term of the frequency term, this is the come in the that is the transfer of the signal will be like that only. So this is the one questions that a transmission fiber of length 80 km has that Gaussian wave dispersion of 70 picosecond. D is given at 70 picosecond per lambda, lambda is given 50 nanometer. So dispersion coefficient of the fiber is given at 130 picosecond square per kilometer. Suppose that power at the input side is 1 milliwatt. Loss of the transmission fiber and DCB are that you have to given that. Consider spice loss of 1 dB between the transmission fiber and DCB. Find the DCB length required for the dispersion composition. What will the power at the output of the DCB? So first we need to convert the GVD to beta. So this is the formula that minus lambda is equal to 2 pi c into beta. So beta is the phase constant. For dispersion composition, we know that beta 21 L1 equal to, this is the condition for dispersion composition. So 1 milliwatt of energy power means 0 dB. For 1 milliwatt, I have converted into a dB scale. So loss in the transmission fiber is 0.2 into 80 kilometer, because you have to given that transmission fiber loss alpha equal to 2 and the total length is 80 kilometer. So it's 60 dB. Loss in the DCB you have to calculate. Splice loss you have to total loss you have to calculate that the output of DCB should be whatever the input of that 0 dB minus, this will be minus 236 dB. So you have to calculate, you have to consider all the losses, and whatever that power through the transmitter, you have to given the receiver, you have to given that total output power is minus 23.75 dB. Okay. Anything else? Manish and Jagannath.
No, it's fine, but in I have a
No,
doubt
sir.
in 7, the
Yeah.
assignment. I have a doubt in
Sir,
question
question number 7 and 8 of the.
C. They are asking the find the non-linear phase accumulated over 80
A
kilometers.
Gaussian pulse with peak power P naught is defined. That you can. That questions.
Yes, yes, yes.
Yes,
So,
sir.
so what they ask that find the maximum frequency derivation over 80 kilometer when the peak power is that.
No, non-linear phase accumulation.
Yeah.
They are asking non-linear phase accumulation. What is this?
Non-linear phase acceleration over 80 kilometer when the peak power
In the
is.
Yes, sir.
last video in the week, I think introduces all of the concepts required. I think the self phase modulation. The last video of the week is called self phase modulation. Yes. Uh, I think all of the concepts are covered in here.
Yeah, there is a one effect that linear effect index and that they are given that A effective and in the last lecture that the noise non-linear phase noise they have given you duration and the presence of that. So Manish, that signal that you have to the signal we have to that signal we have e equal to we have written at e equal to e की power minus j e की power minus omega t minus beta z through that. One you have to calculate through the non-phase that beta you have to calculate that in case of that equal to 2 pi upon lambda you have to given that formula n0 plus 2 n2 upon a effective where a effective is the effective area of that signal. So effective area you have to give that I equal to P upon A effective area. The P is the power and I is the current or signal maximum signal. So effective area is not the area of the core but the area of that mode of the fiber. So you have to calculate through that beta you have to calculate through that formula and so L effective you have to calculate in this case is equal to 1 minus exponential minus alpha L upon alpha. So you have to given that alpha and length into attenuation constant you have to given that length and you have to given that you calculate that alpha. And one formula you have to use that phi that non-linear phase that mode deviation equal to phi and L equal to gamma P in into L effective. So gamma you have to already gamma value is to given that 2 watt per kilometer per. So your P in you have to given that 1 milliwatt in one case and L effective you have already calculated. And you have to calculate that broad pulsing through that minus gamma dp by dt upon maximum upon L effective. So for Gaussian pulse with the peak power P naught that formula that you have given that first Gaussian pulse that P naught equal to exponential minus T0 equal to T naught. So through this you to calculate that full with half maxima. So you calculate the maximum deviation to that dp beta dt. So that formula to that you to take the derivation of the dp by dt and if you take the maximum of the dp by dt you can calculate that broadening of that deviation through the delta omega. Okay. Hello.
Yeah.
So whatever that your power that Gaussian power you to calculate you just make the derivation of that dp by dt and you take that value of that p0 in that case the p0 and t0 you have to calculate that this value have to given that full width half maxima equal to t0. So that value you have to put in that t0 value and for one pulse Gaussian pulse so you have to take the maximum that value of the t equal to t naught by root thus then just you have to put that value and take the deviation and through this you can calculate that maximum value that rounding of that delta omega. Okay.
Okay. Let me try.
If you have not solved then please write us I will help again that you.
Sure.
Okay, you have try first and if you have any face you can write me on that Google Classroom or in email or whatever that you.
Sure.
Okay.
Okay.
So before that assignment submission you can write us. So if you have any problem, if you have not got the answer, then I will help you then.
Okay.
Okay. So Zonek, anything else? We can finish.
Yeah, sure.
Any other questions?
No. Thank you.
Okay. Thank you everyone.
Sir,
Yeah.
So we can mail you if you have any doubt.
Yeah,
Uh,
yeah. On ask to
by
question form, you can write that. We have access of that. We have every time, every day we visit that ask to question form, and we have to try to reply on that only. That.
okay, sir. Okay, sir.
So you can put your query that on ask a questions form, and we can reply on definitely on that.
Okay, sir.
Okay. Or even you
Thank you,
can
sir.
put me on that Google Classroom. I have created that. You can put all that also on that. I will reply on that also. Then.
See,
Sir, in
sometime
the
what
Google
happened that
Classroom.
sometime what happened that ideas or concept was okay, but due to calculation mistakes or something else, we are not being able to choose the correct answer. By virtue of which we are not being able to score in the
So
assignment.
that's why you have to given that range of that. We have provided you the range. In between range, your answer will come. It is okay for that.
No, no, no. Especially for the MCQs.
Okay. You can put that answer that we can verify if you have any problem. We can make sure that your calculations we can take care of that also. We can verify that.
Sure, sure.
Okay.
Okay.
You
Thank
solve it and you can click the photo and send us in a PDF format. We can go through your calculation or that whatever we can highlight that and you can send again.
fine, 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 fine.
Okay.
Okay. Thank you so
Okay,
much.
Manish. Thank
Okay.
you.
Thank you.
Janek, can we stop? Janek?
So let's try to meet on Sunday morning or something.
Y- Yeah, Sunday 10 to 12 or Saturday, whatever that, you can write that email to that there.
Yeah, let them read up on Saturday maybe. And
Yeah,
Sunday morning, 1 hour we can do.
yeah, we can do the Saturday, but Saturday I have 10 to 12 meetings, so put after 12 that.
And what about Sunday?
Sunday it is free for me that.
Yeah, like Sunday before lunch.
We can put on Saturday 10 to 12 to 11 or 12 to 12:30 to 1:30. I think Saturday is the best option.
Yeah,
Janek?
Saturday or Sunday, I don't know.
Saturday is just okay for that, everyone, I think that. Because Sunday someone maybe Sunday 12:30 to 11:30 1:30 you can do. I am okay with Saturday and Sunday that no problem that.
Yeah, like, they also need some time. They're complaining that
I
they
think
don't have
they
time
are
during
free
the
on the
week.
Saturday maybe because Saturday have also some are people are joining that institute or that, so they have the not the 5 week day, they have the Saturday is also working some offices and that.
Yeah, yeah,
So Sunday is the best. We can put 12:30 to 1:30 or like.
yeah, yeah.
Okay.
Anyway, let's talk to man, then I'll talk to NPTEL. Also, we don't need support from NPTEL because we already have the link. We can have this meeting anytime.
Okay, okay. So we can tomorrow we can discuss to ma'am that or ma'am will be not joined then you can discuss with that.
Yeah, yeah. Okay.
Okay,
Okay, see you.
okay. Thank you.